Welcome to the station on unit rates and complex fractions. So I'd like you to take a few notes on this. The skill we're going to be dealing with in this video is dealing with a complex fraction. Okay, kind of a complicated word. We have touched on it a little bit in class, so hopefully some of you will catch on to it real quick. Before we start, let's just review. If you haven't been to the station yet on unit rates, I know that in 6th grade you guys talked about the idea of a unit rate. The word unit means one, and the idea of rate means that it's a ratio where there's two different quantities being represented, like miles per hour. Since you've got two different labels, miles in the numerator, hours in the denominator, that's considered a rate. That's really easy to remember, a rate. If you think about when we talked about our formula distance equals rate times time, rate was also referred to as our speed. So it's real easy when you hear the word unit rate, think about a common speed, and you would never say that you're traveling 50 miles. That doesn't describe a speed because a speed has to tell miles per time. So miles per hour. Feet per second. A rate can also be how quickly you're typing. Like we talked about words per minute. So keep that in mind. So a unit rate is a rate where the denominator is a 1. So 50 miles per hour makes sense to all of us because that's how our system works. If you look on a speed limit sign, it says 50 miles per 1 hour. It doesn't say you're driving 210 miles per 2.67 hours. That speed would make no sense to us because we have no frame of reference for that. We're so conditioned to know how fast something is per 1 hour that this rate is really unusable for us. So you're going to be working with reducing rates so that you have a denominator of 1. But in today's work, we're going to kind of get into a complex fraction, and a complex fraction is when you have a fraction within a fraction, and I'll show you what I mean here. If you take a look at this speed skating example, it says Dana is skating laps to train for a speed skating competition. She can skate 1 lap in 40 seconds. So if we were to turn that into a rate, she can do in 40 seconds, she can do 1 lap. And that's nice and easy. That's already a unit rate. And we're good to go. But the question might come up, what would happen, or how would we figure out how many laps she could complete in 20 seconds? So, if you notice here, to create an equivalent ratio, aren't we just dividing this by 2? 40 seconds getting cut in half to 20 seconds, so we would cut our laps in half and we would get half of a lap. And this right here is what's called a complex fraction. It's when you have a fraction within another fraction, and we want to learn how to deal with this. This is not an appropriate way to leave an answer, to have a fraction within a fraction, and so you have to do a little bit of math to it. So hopefully you guys will recall, doesn't this big bar here mean division? So this really means 20 seconds divided by 1/2. So if we were to write it like this, you should remember that our definition of division means the first number stays the same, but we multiply by the reciprocal of the second number. So if you multiply 20 times 2, you get 40 seconds per 1 lap. Okay, so to work for a complex fraction, to get rid of this fraction, we're going to learn this technique. Okay, so in your notes, we're going to try a few. So the first one I'd like you to try is, let's do this complex fraction. 2 divided by 2/3. Okay. You can do this a couple of different ways. You can write it like this. 2 divided by 2/3 looks like this. and 2 divided by 2/3 is the same as multiplying by the reciprocal. We're left with 6/2. 2 times 3 is 6, 1 times 2 is 2, and 6/2 is the same as 3. So our answer here would be 3. Okay. Here's a way that your high school teachers will show you. A shortcut to that is, in order to get rid of this fraction in the denominator, what could we multiply this denominator by to make this be a 1 down here? And hopefully you'll recall that if you multiply by the reciprocal, we've talked over and over again this year, those things reduce to 1. But to be fair, whatever you do to the bottom of the fraction, you also have to do to the top. So if you're going to multiply the denominator by 3/2, you need to multiply the numerator by 3/2. Now if you notice, this is all going to cancel to 1, and aren't we left with the exact same multiplication problem as we had up here? So either way, you get to the same result. 2/1 times 3/2 equals 6/2, which is 3. Okay. All right, let me try one more that ties in with unit rates. If it looks like this. Josiah can jog 1 1/3 miles in 1/4 of an hour. Find his average speed in miles per hour. So we do miles on top, per hour. So we're going to set this up. Now this is not in miles per hour, it's in miles per 1/4 of an hour, so we want to get rid of this fraction down here. Well, hopefully you remember that from the last lesson, or the last example, how can you get rid of 1/4? Multiply by 4/1. What you do on the bottom, you must do on the top. These things are all going to reduce. So you're left with 1 hour on the bottom. And on the top, we now just have to take 1 1/3 miles and multiply it by 4. Well, recall that before you can multiply 1 1/3, you need to turn this into an improper fraction. So 1 times 3 is 3, plus 1 is 4, so you get 4/3. Okay, so let's reduce that. That becomes 16/3. 4 times 4 is 16. 1 times 1 is 3. So it's 16/3 miles per hour. And still, that's not real usable. Let's turn it back into a mixed number. 3 goes into 16 5 times with 1 left over. So it's 5 1/3 miles per hour. Okay. All right. That's it for the video. I'm going to have you guys work now in your groups on solving some unit rates with complex fractions. Thanks.